So in this video, we are going to talk about solubility and the generic properties of solubility. Solubility is very specific and unique between ionic substances versus metallic substances versus molecular substances. But there are some things that are true no matter what kind of material you have. So that's what this video is going to have us go through. It's going to have us go through something called a solubility curve. So you can see one over here on the right. Notice there are very different lines. Each substance has its own unique solubility. So when you're talking about solubility, you can't do it generically. You have to be very specific about the material. Notice the other parts to the graph. You have temperature. As temperature increases, what do you see happening to most solubility things? All of those increase for the most part. Those are all ionic substances. They increase for the most part. One exception is this C2SO4 or Ce2SO43 material. It decreases a little bit. And you also see a big decrease in ammonia. But ammonia is not an ionic substance. Ammonia is molecular. It is a gas. So solids, for the most part, have a direct relationship between temperature and solubility. If you increase the temperature, you add more energy so you can pull apart the molecules a little more easily. Gases behave a little bit differently. Gases have an inverse relationship with temperature. As you increase the temperature, the solubility of a gas decreases. We're going to save that idea until we get to the gas unit to talk about why that is. But we want to focus for the most part on these solids. Okay, so in addition to temperature on the x-axis, notice that I have a kind of complex unit on the y-axis. Not only do I have grams of solute, I have per 100 milliliters of water. So you need to specify how much solvent, in our case water, is being used. Because if I double the amount of water, that means I can double the amount of solute. So I need to know how much water, how much solvent I'm talking about when I create the solubility curve. So solubility is dependent upon three things. What the nature of the solute itself is. Is it KCl or Ki or KNO3? What is the temperature of the water that you're using to dissolve the solute? And then how much water or solvent are you using to dissolve the solute? So there's three properties that really have an impact on solubility. What we're going to do now is we're going to look at a different graph. I'm going to ask you to label this graph with a couple of things. Notice some of the terms. Like I said, we're going to do generic stuff. Generic terms are saturated, unsaturated, and supersaturated solutions. So that's what we're going to look at. I am actually going to shift to a different graph because it's a little bit bigger and I can write on it better. Okay, so I'm going to use this one. Back up the video a little bit so you can see the whole thing. This is identical to the one that you have. I just have made it bigger. So first point we're going to show is the saturation point. So that's the first word, saturated solution. This line represents the saturated solution. Now I'm going to focus on KNO3 because it's nice and gives me nice and big spaces on either side of it. Okay, so this point right here, right on the line, represents the point of saturation. If you have, for example, 30 grams of KNO3 at, or 30 degrees water, I can dissolve 45 grams of KNO3. It's a little cleaner to see at 30 degrees. I can dissolve about 45 grams of KNO3. If I increase the temperature of that water to 70, now I can dissolve 130 grams. So the saturation point is the point where you can't dissolve anymore. So at the point of saturation, it's like a sponge. If you saturate a sponge, that sponge can't pick up any more water. If you saturate a solution, you can't dissolve any more solute in that quantity of solvent at that temperature. So this line represents the point of saturation. It's the maximum amount of solute that you can dissolve in the given amount of solvent at that temperature. Now, if we are looking below the line, anything below the line represents an unsaturated solution. An unsaturated solution means that I could dissolve more solute in the water. So if I have that 30 degrees again, I can hold 45 grams of KNO3, but what if I only dissolve 20? I'm below the curve, so I have an unsaturated solution. I could dissolve another 25 grams of KNO3 and still have it dissolve. Okay, so anything under the line represents an unsaturated solution. Above the line, now we're going to do two different things above the line. Most of the time, if you are above the line of saturation, what you have is a saturated solution with excess solid. So what I mean by that is, if I have that 30-degree water, but I try and dissolve 70 grams in it, 45 will dissolve, but the other 25 will stay as a solid sitting on the bottom of the beaker or the test tube or wherever it is that you have the solution. Okay, so usually when you are above the line, what you have is a saturated solution with excess solid. So you have the maximum of solute dissolved, but then you have extra solids sitting in the beaker. On the rare occasion, you can create what is called a super saturated solution. If you have a super saturated solution, it means that magically all the solute is dissolved. Even though you shouldn't be able to dissolve, even though you shouldn't be able to dissolve that much stuff, it does. It super saturates. That's a very rare. Again, even on the organizer that you have, I have the word rare down there. That's a very rare situation. To have a solute go above the saturation point and stay dissolved is not easy to do. I've got a video that I'm going to show you and we'll talk about how that all works. Okay? But most of the time, under the line, again, we're just going to do a review. Under the line, in the blue area, you have what's called an unsaturated solution. You could still dissolve more solute. If you reach the line, you now have a saturated solution. So now you've reached the maximum point of solubility. No more solute under normal conditions can be dissolved. If you go above that line, you will have the saturated solution, but all the extra solute will be dissolved, will be sitting on the bottom of the beaker undissolved. Okay? Again, on the rare occasion, you can supersaturate something. So this kind of graph applies to no matter what kind of substance you have, whether it's molecular or ionic. Like I said, these are ionics, but molecular solubility curves look very much the same. Again, it depends upon how those molecules interact with water, but you still need to know what the temperature is, you need to know how much solvent you have, and you need to know how much solute you are dissolving. All right, so let me pause for a second. I'm going to get the video set up to show you the supersaturated solution. This is a pretty cool thing. Okay, so what they have here is they have a supersaturated solution of sodium acetate. So in here, they have dissolved more sodium acetate than you should be able to dissolve. Sodium acetate is one of the rare substances that very easily supersaturates. And so what you are going to see is they're going to show you what happens, and I'll try and fill you in a little bit as we go. So play the video. So what you see happening is all the excess crystals coming out of solution. Isn't that cool? All those solid crystals are the quantity of sodium acetate that should not have been dissolved in water. So again, what you're seeing is initially what happened is a crystal came out of solution, or there was a crystal in the, oftentimes there's what they call a seed crystal in the petri dish. And as soon as the supersaturated solution hits that one solid crystal, it's enough to cause all of the other crystals to start to stick to it. And those crystals, that amount of sodium acetate that should not be dissolved in water starts to precipitate out, and this is what you see. Pretty cool stalactite or stalagmite. Stalagmite, I guess. Stalactite is from the ceiling. Stalagmite is from the ground. There's your geology lesson for the day. So you can see that we're growing this material as we slowly pour the supersaturated solution out. Now, this is not a complete solid. This is actually a saturated solution. There is still liquid there, although it doesn't look like it because sodium acetate does a super job of supersaturating. But it's a pretty cool demo to do.